Hello everyone, this is Professor DePaulo. Welcome you back to Psych 265 fully online. And in today's chapter, we're going to be talking, or this week's chapter, we're going to be talking about correlational research. And I'll be talking about surveys, looking at data. So we've transitioned now from qualitative to more quantitative analysis at this chapter moving forward. So we need to pick the best design. We talked about the benefits of qualitative research before, and now we're going to talk a little bit more about quantitative research. There are several limitations of qualitative research, and the major limitation is qualitative research is not good for identifying relationships between variables. Yes, you get descriptive information, and this can be very useful, but you don't get a cause and effect, conclusions. You can't draw those kind of conclusions from qualitative research. You don't get the magnitude of relationship between variables, and that's what you're going to get in a more quantitative setting. And a lot of qualitative research is also observational research, and observational research is limited to variables that are easily observable. If you're trying to do research on internal mental states, you can't do observational research on that. You need to do some kind of self-report or even a behavioral design to sort of measure these variables. And there's a lot of utility of survey research. Having done survey research for years, I could say that it's not perfect, but it gets you a lot of interesting data. Much of this data is valid. That means it's actually measuring what you claim to measure. There are some pitfalls with it. It's not perfect, but it's pretty easy to collect a large amount of data. It's relatively affordable as well, and it's less time consuming than doing sort of very demanding qualitative research. And a lot of the survey-based designs are looking at correlation. So it becomes a correlational study, and you can see the relationship between two or several variables at once. And just remember that correlation is not causality. You need to run an experiment with random assignment to draw cause and effect conclusions. So if we're going to design a survey, we typically have to use some kind of scale on the survey. Now we can ask open-ended or closed-ended questions as a measurement. Open-ended questions are basically the participant writing down their answer, or in the case of an interview, they will give their answer in their own words. Closed-ended question is when you have a predetermined set of response options, and this is the key to a survey, is you ask a question, you give the participant a series of answers, and they have to pick one or more of them. And so those are closed-ended questions. So any kind of measurement scale that you're using in a survey will be closed-ended question, and your goal is to try to develop a question or a series of questions that measure appropriately the variable you're interested in measuring. And you can write your own scale or develop your own scale. That's very difficult. I've tried that before. It sounds easy. Oh, okay, I can just write questions that I want to ask and it'll be okay. It's not that easy. And the reason why it's not that easy is because your scale that you develop has to be psychometrically sound. That means you have to have appropriate reliability and validity, and those aren't as easy to get when you're writing your own survey, just kind of off the top of your head. So there's ways to develop a good survey if you're creating it on your own. However, why create a survey on your own when there's plenty of scales out there? Survey or scale I use interchangeably. There's plenty of scales out there that you can use for free that have already been validated. So reliability and validity has been shown for the scale. So you don't have to worry about that. You can just use someone else's scale and then conduct your research using a already existing supported scale. And you can find them all over online. You can do a literature review, and sometimes at the end of the article, you'll find the instrument or the scale that they developed. That's if you're lucky. You can always find that. There's a couple websites that I've given you to search for scales. You can find scales that already exist on those two websites. Or you can just Google. Just Google in like anxiety scale or anxiety scale doc if you want a Microsoft Word document, anxiety scale PDF if you want a PDF document, and see what comes up. And you're going to get a lot of scales. You may not get every scale you want, but there's a lot of scales that are free of charge. There are some that you have to pay for, but when you're doing research, you want to use things that are readily available, and you don't want to really necessarily pay for things that you don't have to pay for. So there are plenty of good scales that are free of charge you can find online. You just have to look for them. Here's what a typical scale looks like. You ask a question, and you give them, a closed-ended question here because there's a limited number of options. Strongly disagree, disagree, agree, strongly agree, not applicable. This is called a Likert scale, or a summated rating scale. So each participant evaluates a question using a set of predetermined options. And this is a very typical scale. There's 5 options, you pick one. And then afterwards, when you code it, you assign numbers to each of these 5 options. So strongly disagree could be 0, and then disagree could be 1, agree could be 2, or you can use negative and positive numbers. It really depends on how you want to analyze the data. But you would assign a numerical value to each of these options, and then you would compute the scale that way. Here's a sort of blown up version of the Likert scale. As you can see, it's strongly disagree, disagree, either agree or disagree, agree, strongly agree, and there's numbers here, and you would just code those numbers. And if the item is reverse coded, which we're going to talk about, you would reverse code the number as the score for that item. So five choices is very common for a Likert scale. You can see 7 choices. The only problem with having an odd number of choices is people might pick the middle option. And if people keep taking the middle option or selecting the middle option, you're going to have central tendency issues, and it's going to be tough. So sometimes if I feel that people are going to just pick the middle option, instead of giving an odd number of choices, I'll give an even number. So I'll give 1 through 4 instead of 1 through 5. And that way they can't pick the middle option, if you see that being a concern in your study. So if you're going to make your own scale or survey, how do you write high quality items? Well, the general tips are pilot test the items. So brainstorm them first, then pilot test them. That means, take the scale, give it to a small number of people, and see what kind of feedback they give for you. So maybe your participants in the pilot study say, I don't understand this question. And then you go back and you read it and you realize that, they're right. You don't understand the question either. It's not written properly. You need to change it. So pilot testing is an important technique or important strategy before you end up conducting the whole full-blown study with everybody. You could also have a panel of experts judge each item. So you bring in a bunch of people that have expertise on whatever your study you're conducting, and then you have them judge each item to see what do they think of the item. Do they think it's appropriate for the scale that you're trying to create? And that's helpful. As far as writing the questions, you want to be clear and precise. You want to avoid jargon. That means don't make it too scientific. Don't make it too related to your field that a regular participant can't understand what you're asking. And you want to avoid double-barreled questions. Those are really problematic. And here's an example of that. Did you find the classes you took during your first semester of college to be more demanding and interesting than your high school classes? As you can see, it's double-barreled because you're asking about demanding, and then you're also including interesting. So the person doesn't know, are they answering it with regard to demanding, or are they answering the question with regard to interesting? Because there are plenty of demanding courses you don't find interesting. There's plenty of interesting courses you don't find demanding, and there's also plenty of courses that are both demanding and interesting. So you're trying to assess only the situation where the class is both demanding and interesting, or are you trying to assess demanding and or interesting? As you can see, there's two options here, and it's confusing, and different participants will interpret this question differently. And that's not what you want. You want the question to be clear to all participants. So this is a double-barreled question. You want to avoid these things. These are quite common. You see them in surveys that are not properly kind of worked out and piloted. We also have to be aware of acquiescence, or the acquiescent response set. So a response set or response bias is when a participant tends to agree with most, if not all, the items on the scale. So you ask them a question, they put 5, 5, 5, 5, 5, and they just strongly agree with everything. And maybe they do strongly agree with everything, but there's also the chance that they're not really kind of reading through the questions. So that's what you want to be careful of is, are people actually reading the question and answering honestly? Or is the participant just putting 5 for everything because they want to finish the survey really quickly? And if that's the case, you're not going to get good data. So what you can do is you can reverse code items. So you can ask some questions, straightforward, and other questions you can reverse code it so that, putting the answer 5 is not going to make much sense. And you can actually see if the person kind of gets tricked up. And if they're still answering 5 to everything, they're not reading the question. You know right away that that person's data is not going to be usable. You're going to have to discard it because they're not actually reading the question. Here's an example of some reverse-coded items that I use quite frequently. And this is the Rosenberg Self-Esteem Scale. So it's 10 items measuring self-esteem, but the answers with the double asterisk are reverse-coded. That means the question is asked in reverse. So if you look at question 1, I feel that I'm a person of worth on an equal plane with other. Okay, if I strongly agree with that, that means you have high self-esteem. Question 2, I feel that I have a number of good qualities. If you answer strongly agree for that, then you have high self-esteem. But look at question 3. I'm inclined to feel that I'm a failure. So now you want to answer 1. So if you have high self-esteem, you're going to strongly disagree with this question because it's reverse coded. It's not coded so that 4, or the highest response, means self-esteem. It's coded that the lowest response means self-esteem. So the participant actually has to read the question to understand this. If you see strongly agree with everything here, that means the person's not reading the actual question. Because they wouldn't strongly agree with other items of self-esteem and then strongly agree with an item that says they're a failure. That doesn't make much sense. So chances are they just didn't read it and they just started circling the highest value. So that would be a response set. And that's what I described before, and that's what you want to avoid. So if you're trying to avoid response set, try to put in a few reverse coded items to check to see if your participants, the people taking the scale or the survey, are actually reading the items. You also have a different type of response set, and this is called central tendency. And this occurs when people will just circle the middle number. So how do you feel about this? Neutral, 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 neutral. So you go through their whole survey and you just see neutral for everything. Once again, they're not reading the question or they just don't care. And unfortunately, with survey research, that's a problem. Participants don't care. They're either getting paid for doing like online surveys, or the survey's long and they get tired and just start saying whatever. I'll just circle either 5 or circle the middle number just to, get through it. I've had entire surveys before, multiple times, where the participant just circles the middle answer every time. And I took the survey and they just tore it up in half and threw it out. Because this is not accurate data collection. I mean, I can't use this person's data if they're going to write neutral for every question. And I've seen this before. I've also seen strongly agree for every question that I showed you before. People are lazy. They don't care about your research. They're doing it for class credit or they're doing it for money. And this is a real problem online when people are doing surveys for money. So people go online, they complete a certain number of surveys, they get paid for it, but they're trying to get through them as quickly as possible. And so they're going to be more likely to have this kind of central tendency or response set when they fill out the surveys. So always be careful of this. And one way to avoid this is have an even number of options. So if you have an even number of options, you won't have this, circling the middle every time, because there will be no middle. So strongly agree, agree, disagree, strongly disagree. There's only 4 options there. There's no neutral. So since there's no neutral option, they're going to have to choose something. And if they have to choose something, they're going to have to read the question. Neutral or the middle option is something something you don't want to really have in your surveys. I don't like to have sometimes or neutral, because right away people want to circle that. And they may be trying to tell you the truth, that they really don't care, or it really is sometimes. But more likely than not, they're circling it just to get through the survey. So use an even number of response alternatives and you avoid this problem. You can also avoid this problem by giving them something like a forced choice scale, where they have to pick true or false. So there's only 2 options. They have to pick one. It's very hard to just say true to everything. You actually have to read the question before you pick an answer. This gets rid of that problem of central tendency as well. Now, if you're calculating a participant score on your scale, remember that if you use reverse worded items, like I showed you with the Rosenberg Self-Esteem Scale a couple slides back, you need to reverse score it. So if the original score is 1, strongly disagree, when you reverse it, it's going to be 5. If the original score is 2, it's going to be reversed as 4. 3 obviously stays the same. 4 becomes 2, and 5 becomes 1. And that's how you reverse score scales. So any item that needs to be reverse scored, you need to flip the scoring, and then you add up all the items together to give you a total score after you reversed the ones you need to be reversed. Now you've come up with a scale, you figured out how to reverse code certain items, you determined how many response options for each question, so you're well on your way to completing the scale. And let's say you finish the scale and it has 20 questions, and you want to know, is it a good scale? Well, we need to evaluate it psychometrically. The first measure of psychometric evaluation is called internal consistency, and it's a form of reliability. This is the degree to which all the questions or all the items on the scale are related. So do all the items in the scale go together to measure the same thing? And that's very important, because if you're measuring a scale of anxiety, you're developing, let's say, a new anxiety scale, you want all the questions or items on your scale to measure anxiety. You don't want some of them to measure anxiety and some to measure depression and some to measure bipolar. You don't want this. You want every item on your scale to measure the same thing, so they should all be correlated together. Whatever person scores on one item should be somewhat correlated to the other items, because the scale is measuring the same thing, hopefully. And the measure for this is internal consistency. It's a form of reliability, and it's computed using something called Cronbach's alpha. Cronbach's alpha is used to evaluate the internal consistency of a scale. You want a value of Cronbach's alpha greater than or equal to 0.80. That means all the items on the scale kind of measure the same thing about 80% of the time. More technically, it's the average of all possible split half correlations. So if you were to divide the survey or the scale in half, every possible way you could divide the scale in half, and then you were to average out all those split half correlations, correlate the first half of the scale to the second half of the scale, correlate the odd numbers to the even numbers of items on the scale. If you were to divide up your scale in half every possible way and then correlate that, and then you took the average of all the correlations, that would give you Cronbach's alpha. And we would want that correlation, that Cronbach's alpha value to be higher, greater than or equal to 0.80. If it's less than that, it's a little bit troublesome. 0.70 is okay. Anything less than 0.70 in your scale is basically done. You can't use it because you don't really know what it's measuring. It's measuring different things. And so then you might have to set up subscales and then conduct a Cronbach's alpha for each subscale. And you could set up subscales using factor analysis or principal components. So if you run this advanced multivariate technique called principal components or factor analysis, it will give you the structure. It'll tell you which items on the scale are kind of grouped together. So that could be another way to determine, do I need to sort of set up subscales within my survey, or are all the items on my survey measuring the same thing? That's kind of more advanced, and we're not going to talk about that, but that's what you would do. So besides Cronbach's alpha, which is the average of all possible split half reliabilities, we have another form of reliability that's very useful for a scale, and that's test-retest. So if you take the scale at time 1, and then you wait a certain amount of time and take it again at time 2, you should get a similar score. So if you take 2 scales a week apart, you would hope that your score on those scales would be approximately the same. They're not going to be exactly the same, but approximately the same. If they're radically different, then there's something wrong with the scale, or there's something wrong with the participant. But if you do this with many participants, there's more likely something wrong with the scale. So test-retest is simply a correlation between time 1 and time 2, and then you see, are they related? And you hope that this is 0.80 again. That's the magic number, 0.80. You can also use alternative form or equivalent form reliability. This is useful if you're going to give an exam and you want to have 2 copies of the exam. Test A, form A, and form B, because you're afraid people are going to cheat on the exam. So you give one row of students form A, you give the other row of students form B, and the questions are somewhat different. And the goal is, look, you don't want them to cheat, so you give them different tests. You would want those tests to be pretty much highly correlated, because you wouldn't want to give half your students an easy test and half your students a hard test. You want it to be relatively equal, but you also want the questions to be different so they don't cheat off each other. And that's when you would use this alternate form or equivalent form reliability. So you have 2 versions of the same exam or the same scale, and you want to see, do they go together? They should be 0.80 or higher again. Here's a review of the different types of reliability. Internal consistency is Cronbach's alpha. How interrelated are the individual items in the scale? Do they go together or not? Test-retest means, do you get the same score at 2 different time periods on that scale? And alternate forms is, how consistent is the scale with another measure, comparable measure of the variable? So this is, 2 different forms of the test, and you hope that they go together. So let's look at some scenarios here to decide what kind of reliability is being assessed. Here, Julie is going to measure a person's mood before and after a stressful situation. She's worried that if a participant sees the same mood questionnaire before and after, it will change his or her responses. Therefore, Julie decides to create 2 different mood inventories composed of different questions. So here we have 2 different scales. They have different questions, but they're supposedly measuring the same thing. To assess this reliability, she brings in 20 people to administer both forms to these group of 20 pilot participants, and then correlates the scores on the 2 inventories. So the idea here is there's 2 scales or 2 tests, and they're slightly different, and Julie wants to know, are they equivalent? Can they be considered equivalent? That means basically, are they measuring the same thing, even though they're different? They're worded differently, or they have different items on the 2 scales. So based on what we learned before, We know it's not internal consistency because that's for one scale. Here we have two. It's not test-retest because the same people are not taking the test twice. So for this to be test-retest reliability, the same participants would have to take the same scale at two different time periods, and that's not what's happening here. Here you have 20 participants taking two different scales at the same time and seeing if those scales are equivalent. So we have alternate form reliability. So internal consistency would have been one scale, the items in one scale, do they go together? Test-retest would have been the same scale twice at two different time periods. And here, alternate forms means you have two different scales, but they measure the same thing, and you administer them relatively simultaneously, right? One after the other. And you hope that they agree, they correlate. And that's what we have here. Here's our next situation. Roger has developed a test of depressive symptoms. He gives the test to 12 of his patients in October and then again to the same 12 individuals in December. Next, he determines the correlation between the two testing sessions. So is this internal consistency? Well, no, because there's actually someone taking the scale twice. They're taking it in October and the same scale again in December. And we're not looking at if the items in the scale are related. We're looking at if the two tests taken a few months apart are related. So it can't be internal consistency. It can, however, be test-retest reliability. You have the same participants taking the same scale at two different time periods, which means test-retest reliability. And it's certainly not alternate forms because there's only one form. There's only one test. It's the same test measured at two different time periods. So this would be test-retest reliability. Here we have our third scenario in which Dr. Woolley administers an inventory she developed to measure college students' levels of motivation. She then evaluates the degree to which the items are interrelated. This has to be internal consistency. It's one measure. It's administered one time, and she's interested if the items on that scale are related. Do they measure the same thing? And therefore it has to be internal consistency, and the measure would be Cronbach's alpha. You would want 0.80 or higher. Can't be test-retest because it's only administered once, and it can't be alternate forms because there's only one form. So it has to be internal consistency in this scenario. Here's scenario 4. Professor X, I guess that's Professor Xavier from X-Men, wants to assess the level of pre-existing knowledge for students in his upper division psychology class. On the first day of class, students complete the final exam that Professor X administered to his introductory psych class. Then a week later, before any content is introduced, Professor X gives them the same exam for a second time. So this one's pretty easy because you're getting the same exact measure, scale, test at two different periods of time with the same participants. So therefore, it has to be not internal consistency, obviously. Must be test-retest reliability. Cannot be alternate forms. So in this case, another example of test-retest reliability. So hopefully these examples kind of clarify these three different types of reliability that are very important and when you would use each one. So now that we talked about reliability, which is consistency of a measure, how consistent are the scores, within the test itself, within items of the test, within the two administrations of the test, or across multiple versions of a test measuring the same construct, we are now looking at validity, which is, are you measuring what you claim to measure? The first and the easiest form of validity is called face validity. Does the measure look like, just based on what you're looking at, does it look like it's measuring what it says it's going to measure? So when you look at the test, let's say you're taking a test in research methods, and the first question asks about, Shakespearean plays, you know that test, it doesn't look like it measures what it's supposed to measure. The test is supposed to be about research methods, and instead the first question is about Shakespeare. Um, Chances are that's not a good measure. That's not a valid measure of your ability to understand research methods. So that would lack face validity because you would look at the first question or the first couple of questions and you would say, this doesn't look like it's really testing what it should be testing. You're not doing anything numerical. You're not doing anything beyond that. You're just looking at it and saying, this looks weird. This doesn't look like it's correct, so it doesn't have face validity. Then you have content validity. This is the degree to which the items on the scale reflect the whole range of material that should be included to measure the target variable. So if I gave you a math test in algebra and I only included, very basic linear equations, and I didn't include any other content that you learned throughout the rest of the course, you just had very basic equations that you learned the first month of the semester, that would have poor content validity. Because if the test on algebra is designed to measure your entire knowledge of algebra, everything you learned that semester, and instead you're only getting items that reflect one small piece of the entire course, like solving a simple linear equation, that test would not have content validity. Or if I gave you the final exam and the final exam was supposed to be cumulative, and I only gave you what was on the first test on the final exam, that test wouldn't have content validity. So would it be measuring what you want it to measure? So content validity is the extent to which the measure measures the entire spectrum of the variable you're trying to measure. That's content validity. Construct validity. This is the extent to which the scale measures the desired construct. And there's two forms of construct validity. They're called convergent and discriminant. Convergent validity is the extent to which a scale measures the desired construct by comparing it with another scale that measures something similar. So let's say you're developing a new anxiety scale and you want to see if it's valid. Does it have convergent validity, which is a form of construct validity? What you would do is you would compare that new anxiety scale you developed to a pre-existing anxiety scale. Let's say the Beck Anxiety Inventory, which is a very widely used scale. I use it myself. Or the state trait anxiety inventory. You would want to see, does my new anxiety scale relate to those previously established scales? And if they do, if they correlate highly, positive correlation that is, then you have convergent validity. The new measure correlates or goes with, does the same thing as a previously existing measure that's already been validated and used. So that's helpful. You also want discriminant validity. That means that your scale should not correlate with a scale of something else. For example, going back to anxiety, you developed the anxiety scale. You found convergent validity with another anxiety scale, like the Beck Anxiety Inventory. That was good. Now let's compare it with the Beck Depression Inventory. Your scale on anxiety should not correlate with the Beck Depression Inventory, because your scale measures anxiety and the Beck Depression Inventory measures depression. So you would hope for a negative correlation there, or a zero correlation there. I mean, obviously zero would probably be best. You don't want your scale to correlate with a scale of something that's not related, right? So anxiety and depression are somewhat related, but you wouldn't want a high correlation there. And if you're measuring anxiety, and you could correlate it with satisfaction of life scale, you would expect that your score on anxiety would lead to a lower score on a satisfaction of life scale. So the higher you score on anxiety, the lower you score on satisfaction with life. That would be an example of discriminant validity. that your scale does not correlate positively with another scale that measures something that is not remotely related, or that is in fact the opposite. So you would expect a negative correlation in that case. So convergent means two scales are correlated positively. Discriminant means that two scales are either have a zero correlation or in some cases a negative correlation, showing that they're measuring something completely different. So there's a few more types of validity here to go through. You have criterion validity, the extent to which a measure relates to a particular outcome or behavior. So you want to either measure, there's two subtypes here, you want to either measure concurrent validity or predictive validity. Concurrent validity is how well does your scale correlate with other behaviors of that variable that you're measuring. So let's say I'm developing, in this case, a depression scale. I want to see, does my depression scale correlate with the person's problem sleeping, right? So does it correlate with sleep difficulties? Does my scale correlate with crying spells? Does my scale correlate with the lack of desire to go to work, etc.? Like symptoms or behaviors that are indicative of depression, my scale should correlate with those behaviors if my scale is measuring depression. So that would be an example of concurrent validity. Predictive validity is a little different because concurrent validity is examined at the same time. So I'm examining the scale and the behaviors at one time. Predictive validity is when you take your measure, which is your scale, my depression scale, and I want to predict behaviors in the future. So let's say I want to correlate my depression scale with hospital admission. So people that score high on my depression scale, if I then fast forward 3 or 4 months, they have a higher rate of hospital admissions. Or they're taking a greater amount of antidepressants in the future. So I'm trying to predict something maybe 3 or 4 months or 6 months in the future. So I take the scale now, and then I follow the participant 3, 4, 6 months, a year into the future, and then I measure something then. And I want to correlate my scale with the behavior or with whatever other measure you're looking at 6 or 12 months in the future. That's predictive validity. Can I predict behavior in the future based on the scale that I'm using right now? Another way you can look at this is the SAT. So in high school, students take the SAT scores, or the SAT, and they get a score, right? And the colleges look at your SAT score and they try to predict how well you're going to do in college. So if you have a high SAT score, does that predict success in your first year in college? And that would be an example of predictive validity. I could use the SAT to then predict, do people that score high on the SAT get mostly A's their first semester of college? And they've done these studies and they've shown that there is some predictive validity. It's not perfect. It's not like if you get a really high SAT score, you're guaranteed to get an A in all your college classes. You're not. But there is some, moderate amount of prediction there. So people that score high on the SAT tend to do relatively well in schools. I mean, not perfect all the time. There's a lot of variation, but relatively well. So that would be the SAT has predictive validity towards college academic performance. So here's the review of the validities. Face validity, does the scale look like it's measuring what it should be measuring just by looking at it? Content validity, do all the items on the scale measure the full range that the construct you're trying to measure captures, right? So do all the items on your depression scale measure the full range of symptoms of depression? That would be content validity. Construct validity, does your scale actually measure the intended variable? So does your scale that you develop truly measure this variable? And there's two different types of construct validity. You have the convergent validity, is if your scale is correlated to another scale measuring the same variable, that's convergent validity. Discriminant validity means your scale is not correlated to a scale that is not related to the variable that you're measuring. And then criterion validity is, does the scale relate to a relevant outcome or behavior? And the two types of criterion validity are concurrent validity is, does your scale correlate with behaviors that are indicative of what you're trying to measure? And that is done at the same time. And predictive validity is, does your scale predict future behavior, something down the road? So these are all the different types of validity. And obviously the more validity that you show for your scale or for your measure, the better the measure is going to be. So if you're going to try to publish a new scale or a new measure, you want to show reliability and you want to show validity and show as much as possible. Cronbach's alpha is necessary. You will not be able to publish a scale if you have a poor Cronbach's alpha. And then obviously you want to show validity as well, multiple forms of validity. Increase the chance that people are going to actually see your scale as being good. They're going to want to use it for their own research and they're going to publish it. So here's an example of assessing construct validity between concurrent validity, predictive validity, and discriminant validity. So we're going to try to measure sociability with a scale. So here are some of the items on the scale. Hours spent alone. Now, you see that's concurrent validity because that's a behavior. Hours spent alone is a behavioral measure of sociability. And if there's a correlation there, and there is a highly negative correlation, that shows that there's a relationship. So the more hours you spend alone, the less you're going to score on the sociability scale. That makes sense. That would be showing concurrent validity. Or number of current friends, also showing concurrent validity. The more friends you have, the higher you are in sociability. So that's a positive correlation, 0.89. So this is showing both concurrent validity. The scale is predicting in a way that makes sense the behavior, right? The scale and the behaviors are correlated here. Now for predictive validity, you have to look into the future. So you have a sociability scale score, right? And you're trying to predict number of friends 1 year later, and you see it's 0.70. So that means if you score higher on sociability, on the scale of sociability, you're probably going to have more friends 1 year later. And we can actually follow the people for that entire year and sort of gather the data that way. Now for extroversion, we're looking at convergent validity. So if you're very sociable and you score high on the sociability scale, you should also score high on extroversion, because extroversion is related to sociability. And as you can see there, they're highly correlated, 0.80, so that they are, there is convergent validity because these two different measures, these two similar measures, are highly correlated. Now let's look at discriminant validity. So you want to compare sociability to something that's not related to sociability at all, and that would be neuroticism. So neuroticism is basically anxiety, and anxiety and sociability are not really going to go together. And when we correlate it, we get 0.04, which means basically there's no correlation between your anxiety level and your sociability level, and that makes sense because they're not related at all. I would say they're even somewhat negatively related. They don't go together. If you're sociable, you're probably not neurotic, but maybe you are neurotic to a degree. There's no real rhyme or reason why they should go together, and that's why you get a correlation here around 0, and that shows discriminant validity. Two unrelated constructs are not correlated. That's discriminant validity. Same thing with conscientiousness, which is kind of responsibility. Responsibility and sociability, completely not related. And so therefore you're showing discriminant validity again. Negative 0.06 is close to 0. So now we're going to move past the psychometrics into hypothesis testing. You can have a non-directional hypothesis. You can also have a directional hypothesis. A non-directional hypothesis is a hypothesis that does not make a specific prediction as how the variables are related. So it does not contain a directional term, right? So if you're looking at the role of depression in terms of hours sleeping, right? Your non-directional hypothesis would say that depression has an effect on hours slept. It's not saying that depression increases hours slept. It's not saying that depression decreases hours slept. It's just saying that depression has some kind of an effect. You're not specifying the direction of the effect. You're just saying the effect exists. That means either or. So depression can either increase sleep or decrease sleep. By saying depression has an effect on sleep, you're not indicating whether it's going to increase or decrease. You're indicating both. It could do either one. So that would be an example of a non-directional hypothesis. It does not contain a directional term. Here's another one. Meditation will lead to a change in anxiety levels. Hopefully, it leads to a decrease, but there are some people that can actually have a slight increase temporarily in terms of meditating because they're stressing that they're doing it correctly, and that's increasing their anxiety. Now, if you want a directional hypothesis, you need to specify a direction of the effect. So an example here would be exercise will reduce depression. You're giving a direction of the effect, reduce. That's a directional term. So if you exercise, you should have lower depression. You can actually measure that and test it. If it was non-directional, it would be exercise has an effect on depression, because that means exercise could either increase or decrease depression. That would be non-directional. But for directional, exercise will reduce depression. You could technically say exercise will increase depression, and you could test that hypothesis. That would be directional too. That wouldn't make much sense, but you could test that hypothesis if you wanted to, as a directional hypothesis. So we have our hypotheses down, we have our reliability, our validity, we've talked about the problems with scales, the benefits of scales, and now we're going to try to finalize our survey, and we have to worry about a few other things, including demand characteristics. This is when your participants try to figure out what the study's about. So they're in your study and they're waiting to complete your study, and they're thinking in their head, what is this whole thing about, and what response should I give? How should I act? And a lot of times they're trying to help you out, but in trying to help you out, they're making things worse because you're not getting a true measure of their behavior. They're trying to be a detective and figure out how they should respond to help you out, and instead they're ruining your study. So those are demand characteristics. How could you deal with demand characteristics? Well, you could include items in your scale that are not related to the real purpose of the scale. So as your participants are filling out your scale and they're saying, oh, I know what this is about, I know how I should answer, and then they come across a question that's completely unrelated, and they say to themselves, oh, now I'm not sure what the scale is about. That's a good thing, right? Because you don't want your participants you don't want to bias their responses by having them figure out how they should reply in your scale or in your experiment. They should not really be aware of what you're asking, what you're measuring. So one way that I do this, besides distractor items, which I think are useful, these are like the items in the scale that are kind of bogus items that are measuring something unrelated, just to throw the person off. You don't count them. Those are distractor items. What I do with my surveys a lot of times is I don't write the name of the surveys at the top. So if I wrote at the top of the survey depression scale, you would know what's going on and that would bias your response. So if I don't write depression scale, if I leave it blank, that prevents a lot of times people from sort of guessing what the scale's about, or kind of answering in a way that may be biased. So distractor items, reverse key items, reverse score items. Don't put the titles of the scale on the scale itself. That's a pretty bad idea, because then you're giving your participants an idea what you're measuring, and they may be biased. They may show demand characteristics. So to try to help you out, they're trying to help you most of the time. They're not trying to screw up your research. But by trying to help you out, they're actually screwing up your research. So you want to make sure your participants are not aware 100% what you're asking them and how they should respond. You also have to worry about social desirability, which is a killer, and this is when your participants want to answer in a social desirable way. So they're not being honest, They give you an answer that makes themselves look good. So this is a real big problem when it comes to measuring things like depression, measuring drug, alcohol use. You get a lot of social desirability. People don't want to admit what they're doing. So when you give them the survey on drug use, they all say, "No, I don't use marijuana. I don't use cocaine. I don't use anything. I don't drink. I'm perfectly clean. I'm straight edge. Like I have no need for anything." And you see these answers, and you're like, "Really? Okay." No one uses marijuana. Sure, okay. That's not true. That's not honest. They're just answering this way because they feel that they want to make a good impression. So one way of dealing with this is make the survey anonymous. So they don't put their name on it. And so if they don't put their name on it, maybe they're more likely to answer honestly. Also, I would put it online because that even gives even more of a barrier there. So if they're doing it online and you're not recording their names or any identifiable information, they may even be more likely to be honest with you about these more difficult topics to talk about. You also have the idea of evaluation apprehension. So participants may be concerned that they may affect, what is this going to show the researcher about my behavior? So this is related to social desirability. It's all about, putting forth a good image of yourself, and that can really screw up someone's study. Because if you're not being honest, the data is not valid. It's not valid at all, and you might as well just throw it in the garbage. So be careful if you're designing anything that's, taboo or something that's maybe not comfortably talked about. So that could be sex, asking, a survey about sexual behavior. People are going to say all kinds of things. They may not be true. Drugs, alcohol use, depression, anxiety. People maybe don't want to admit like when there's a problem. They kind of want to look good. And I gave, going back years, I gave 300 college freshmen at Rutgers a depression scale. And one of the questions on the depression scale was, have you ever thought about suicide? And none of the 300 participants actually said yes. And I stood and I shook my head in disbelief. So you have 300 18-year-old students, and none of them have ever thought about suicide. Not even thought about it. And obviously that's a lie. That's not true. It's not like these were the 300 happiest students in the history of the world. No, they're just regular students. And they've had thoughts about suicide. I'm sure they've contemplated. I'm sure some of them have actually attempted it. But they indicated, nope, did nothing, never thought about it, zero. And that was an example of social desirability. They wanted to portray a good image of themselves, and they just weren't willing to tell the truth. Now we're moving on to sampling. How do you select a sample? Well, the best sample you can have, in my opinion, is the simple random sample, where every member of the population has an equal chance of being in the sample. So this is a probability-based sample, and it basically is very fair because everybody's got the same chance of being in the sample. So if you have a large population and you have a small sample, you got to pick from that large population. It can be a lot of work. Even doing a simple random sample at BMCC would be very difficult because you have 20-something thousand students, and you would need to select them at random. Some of those students only come to school on the weekends. Some of them take all online classes. It's not convenient at all for running a study. It's a difficult process, but it is a fair process. And what it means is if you have a simple random sample, then your sample is representative of the population. You don't have to worry about your sample being biased. It's going to be representative if you have a large enough sample, and it's taken as a simple random sample. You can also have stratified random sample, which is when you take the population, you divide it into groups, like male and female, and then you randomly sample from each group. So let's say you wanted an equal number of men and women in your sample. You're going to divide the population in half, men and women, and then randomly sample from the men and randomly sample from the women, and that would guarantee you having an equal number of men and women. So if you want to represent all groups pretty fairly, you can take a stratified random sample. Is it as good as a simple random sample? It's pretty close. I mean, it's not truly random because you're dividing up the population to begin with, but it's probably the second best sample. And this is good if you want to make sure that all groups are being represented in your sample. You can also have area probability sample. This is if you have a large population, you could divide it geographically and then randomly sample from each of those geographical areas. And this would enable you to have equal representation of the different areas that you've divided the territory into. So this is kind of like a stratified random sample. However, what we use most in psychology is a convenience sample. And I haven't written it here because it's really not the best sample to be talking about, but it's kind of the most realistic. And the convenience sample is when you just take whoever's available. So you post a message, I'm doing a study, do you want to participate? And then people say yes. And then you take whoever says yes. There's nothing probability derived from that, right? It's just whoever says yes. And you take who's available. That's a convenience sample. And that's not the best sample to take, but it's the most common one we really take in psychology. And the sample may not be representative of the population because you're just basically taking whoever wants to be in your study. And that causes a problem for generalizing your results. So that means that you have to be really careful to replicate, to redo the study with a different group before you draw conclusions about the general population. So if you're using a convenient sample, you want to replicate. It's very important. If you're using a simple random sample, replication is not as important because you know the sample is representative of the population because it's a simple random sample. So now you have your sample, you can administer the survey. It could be done through an interview where you read out questions and the person provides answers. It could be done over the phone or in person. It could be done, it could be done through Skype, etc. FaceTime. The advantage of this is you can actually look at the participant and determine if there's any confusion. So if you're reading the questions out during an interview, whether it's on the phone or it's face-to-face or it's through FaceTime, Skype, etc., you can actually determine based on the reflection of their answer, on the tone of their answer, whether there's confusion, whether they misunderstood something, whether the look on their face shows them that they're just they're perplexed, they don't know what the question is asking. So that's helpful for these kind of doing things in person or doing things verbally. You don't get the same benefit when doing them as either a written survey or purely online survey. The problem with interviews are, as I mentioned previously, they're very time consuming, they're expensive to conduct. It's a slow data gathering process. It's not my sort of cup of tea. Many of my colleagues like doing interviews. I personally would rather do surveys rather than interviews. Or I wouldn't do a survey over the phone or interview in an interview form, I should say. I like written surveys where I can get lots of data in a short period of time. Paper surveys, which is my favorite, most efficient for groups, most efficient for large numbers of people. Getting data at once, you gather lots of data really quickly, relatively cheaply. It's less personal than the individual approach, but that doesn't really matter. I mean, unless you really need to see their body language or the tone of their voice when they answer the question, if you're not really interested in those things, then paper-based or web-based surveys are much easier to conduct. Even though they're less personal, it doesn't really matter. It's a very efficient way of collecting data. However, it's not as easy to decide or to find if there's confusion in the survey. So if someone doesn't understand the wording of a question, there's no way to know if that affected their answer that they put or they left it blank, because you can't ask them, you can't look at their expression, you can't determine by the tone of their voice whether they're confused. They're just going to do it online or do it on a sheet of paper, and it's not very good at identifying problems. So once again, go back to pilot the study first. Make sure that you're piloting the study and talking to people that complete the survey in the pilot. fix the problems in the pilot, and then by the time you're ready to run the real study, you won't have to worry about this because all those problems would have been identified in the pilot. So this emphasizes even more. If you're going to do a paper or web-based survey, make sure you run the pilot first. Online surveys, very popular. So you get thousands of responses online. You can recruit people through email. I've done it before. You set up an email campaign. You ask people to participate. I've done it at BMCC for studies as well. Can you do it in the general public? Yeah, you can recruit people off the internet. You don't know who you're going to get. You can also do like an Amazon Mechanical Turk, where basically you pay Amazon to go find people to take your survey. And the people get paid. So you access like a subject pool that Amazon has, and you pay Amazon to do this. In the survey platform Qualtrics, you can also pay people to answer your survey. So if you have enough money, you can get responses. You just have to pay for them. Online surveys tend to be more cost effective than interviews because you don't have to hire people to do interviews and you don't have to train them. And it's much faster. The interview process is really a slow process. However, these surveys are rather impersonal, so if you're recruiting people at random, you may have a poor response rate. So if you send out an email to like 100,000 people on the internet that don't know you, and you're recruiting them for your online survey, you're going to get very few responses. If you get 10% response, that might be a lot. So it's rather impersonal. You get low responses, but the good thing is, if you get 10% of the people that you sent it out to, that's still a lot of people because you've recruited from 100,000 people to begin with. So 10% of 100,000 is 10,000. It's a pretty good sample. I've seen people with online surveys get 5, 10, 20,000 responses. You could never get that with interviews. You could never get that with qualitative research. That's not to say that this kind of research is superior. It's a personal opinion. It's just to say that it's much easier to get a large number of responses if you're doing web-based surveys, or even if you're mailing surveys to people's homes, or doing surveys in the school where you're recruiting students. You can get a lot more people in a relatively short period of time to answer surveys, even through email. With interviews and other qualitative research, it's going to take forever. We're talking about at least a year to get enough data to get a big enough sample to really draw conclusions. So, but it's really up to what people are more comfortable doing. Some people love qualitative research. I love quantitative research. I like numbers. I'm really not as interested in the details of qualitative research, but that's the difference. Some of my colleagues love qualitative research. It's just a personal preference. The response rate is the proportion of the invited sample that actually completes a survey. If you're sending blind emails to the general population, they don't know who you are, you can expect a response rate probably less than 20% at all times, maybe even less than 10%. The difference is if you send the recruiting email out to, 100,000 people, even if you get 5% response rate, you're getting a tremendous sample. So send it out to a bunch of people, you might get a low response rate, but you're still getting a large number of people that way. If you send it in the mail, you're probably going to get something less than 20% as well. I think the best way to send these recruiting emails is through email campaign. So there's a bunch of programs that do that. I know Constant Contact does email campaigns, but they're kind of expensive. I'm using some different Zoho campaigns. I've tried to use that before. There's a bunch of different programs out there where you can send email campaigns and recruit people online for things. Now we gathered the data, we sent out our surveys, we have our data, and we're looking to analyze the data now. We've reverse coded everything that was worded in reverse, as I mentioned previously with the Rosenberg Self-Esteem Scale. We've calculated Cronbach's alpha, internal consistency. we've come up with the summary measures, and we summed up all the scales. We have totals for all the scales, and then we can calculate things like mean, median, and mode, which is called central tendency. So most of the time we use means, and we also use measures of variance, which are standard deviations is probably the most common one, right? We don't really use range, and the variance is there too, but we generally report the mean and the standard deviation when we're conducting, research or analyzing results. So the mean and the standard deviation. So mean is a measure of central tendency, or the middle of the distribution. The standard deviation is a measure of dispersion, which is the variability, how spread out the scores are. And those are the two primary measures we use, means and standard deviations. And then we measure associations between variables in the forms of correlations, and we can do regression as well. And there's a lot more advanced stats. You can learn more about stats if you're around next in the fall. You can, fall semesters is when I teach stats. So if you're around in the fall semesters, take my stats course. Some of you have taken it before. This will get you kind of up to date on how to tie stats in with research, because they kind of go together. And advanced stats, there's so many stats you can do when you're testing hypotheses and measuring associations. They're way beyond the scope of this course or any undergraduate course. There's so much out there. There's even stuff out there that I don't even know. And I've taken many, many advanced courses. And there's some stuff out there that people are doing that I'm like, wow, how did you, I don't even know how you did that. So there's lots of this stuff out there for us to just further explore. And as an advanced undergraduate, whether you're leaving here or going to the four-year college, and then maybe eventually to graduate school, you're going to be taking more advanced courses. You're going to learn a lot more about this stuff. Even if you're a clinician, even if you have no desire to learn about research, research is everywhere. Stats is everywhere. You can't avoid it. You're going to have to take it again at some point. Here's a figure just showing variability. You see the variability on the right. There's a lot more variability than there is on the left, because on the left you only have 3 scores, 4, 5, and 7. On the right you see the scores are spread out. So that's what I mean by variability. How spread out are the scores? And the standard deviation is the average distance from each score to the mean. So that's basically the average amount that each score is spread apart from the middle of the distribution or the mean. Mean is only one version of middle. There's, obviously median, which is the 50th percentile, but the standard deviation involves the average distance from each score to the mean. As you can see here, the standard deviation on the right would be much greater than the standard deviation on the left because the scores are spread out more. Here's what a correlation looks like. You see the little r. That's the Pearson product moment correlation. We just call it little r, right? The relationship can either be positive or negative. Positive correlation means the two variables go together in the same direction. Negative correlation means the two variables go in opposite directions. So with a positive correlation, as one variable increases, a second variable also increases. With a negative correlation, as one variable increases, that second variable decreases. So they go in opposite directions. The range of the Pearson R is between -1 and +1 inclusive. So that means you could have the strongest correlation you can have is +1 or -1. Now in psychology, you're not going to get that. You're not going to even get 0.80 that's shown on the screen here. You're going to get maybe 0.50, maybe 0.60 if you're lucky. Probably less than that. A lot of the correlations you're going to see, and you're going to see it with the data I'm going to show you for our results of the study that we did. You're going to see relatively weak correlations. In psychology, we don't have very, very strong correlations a lot of times. We have much more attenuated correlations in the 0.3s, the 0.4s, the 0.5s. Those are where we're sitting with psychology. If you're in the physical sciences, you're going to see much higher correlations. The reason being is you're measuring in the physical science with less error, whereas in psychology, you're measuring with a lot of error. And the reason why you're measuring with a lot of error is because we don't really know what the perfect measure for a psychological variable is. We have to operationally define it, and that doesn't mean it's the best measure. It's sort of our interpretation of what the best measure is. And as a result, we're measuring with a lot of error. Whereas in the physical science, you don't have to question the measurement. If someone says weight, you put the item on the scale and you weigh it. And that's it. There's no measurement error because you put it on a scale and you get exactly how much it weighs. And so when you're conducting correlations in that situation where you're not having any measurement error, the correlations are going to be much higher. But in psychology, it's not like weight. It's not like height. It's not like something that's tangible to measure. We're talking about something like intelligence, where we all disagree on how to measure intelligence. And so if we're all disagreeing on it, there's going to be a lot of measurement error. And if there's a lot of measurement error, there's going to be lower correlations most of the time. So that's why psychology is kind of tough to do research in, because you're dealing with problems with measurement, disagreements with measurement, and of course errors in measurement. Even if I give you a scale, that scale may measure depression, but there's going to be some problems with the scale, right? It's not going to be a perfect measure of depression because A, you have to self-report your symptoms. B, you have to be honest. You can't show social desirability. C, you're not asking maybe every relevant question in the scale, or you're asking it in a way that the person may not understand exactly what you're asking for because the scale may be flawed in some way. No scale is perfect, right? So there's so much room for error when you're measuring things in psychology compared to the physical sciences, physics, chemistry, even biology. The measures are less variable, right? People agree on how to measure things. In psychology, people constantly disagree on how to measure different variables, and that's what's causing these lower correlations. And then finally, once we've computed our correlations and we calculated our descriptive stats like the mean and the variance, standard deviation, we can test our hypotheses, and we can find the probability of getting the results that were obtained or any more extreme results by chance. So this comes in the form of the p-value or the probability value. The p-value that you get from a statistical program, which I run all the time, that p-value is the probability of getting the result that you got or a better result, a more extreme result, by chance alone. That means if your hypothesis is not correct, right? So that means if technically if the null hypothesis is true and your idea doesn't work. So if your idea doesn't work, if your belief is wrong or not conclusive, and the probability of getting the results if your idea doesn't work is very low, then we can say since the probability is very low that your idea doesn't work based on our data, we reject that and we say that your idea does work. It's supported. So the goal of research is to get a very small p-value or probability value. The p-value, once again, is the probability of getting the result that you got or a better result if your hypothesis is incorrect. In more technical terms, if the null hypothesis is true, which you may not understand unless you've had statistics, what that is. But basically, if your idea doesn't work, the p-value is the probability of getting the result that you got or a better result. Now, if that's very, very small, usually less than 0.05, we then technically reject the null hypothesis and we support the research hypothesis. So we support your idea, in other words. So if the p-value is very low, generally the rule is if it's less than 0.05, we support the hypothesis that you generated, that your idea is supported. And that's what we want as a researcher to support our idea, our hypothesis. The probability is p, the p-value that I mentioned before, and we want this to be statistically significant. So this means that the result is not due to chance. So if your p-value is less than 0.05 for your hypothesis, That means that your hypothesis is supported and that your results are not due to chance. They're due to the idea that you're espousing, your hypothesis. They're not just lucky results, they're real results. If your p-value is greater than 0.05, then we say that your idea is not supported and that the results are most likely due to chance. And that p-value more technically gives you the probability of type 1 error. That's what the p-value is. And type 1 error is when you reject the null hypothesis when the null hypothesis is true, which basically means that you support your idea when your idea shouldn't be supported in the population. That's type 1 error. So we want that to be less than 0.05. That's the goal. That's why 0.05 is the magic number. And we're all happy when we get something less than 0.05. And you're going to see in our results that a lot of times we get something that's much greater than 0.05, and that's kind of a bummer. That means our ideas don't really work out. We want p-value to be less than 0.05 when we're testing a hypothesis. And that is called statistically significant. If the p-value is less than 0.05, our results are statistically significant. That means they're not due to chance. They're actually real, and they're due to the hypothesis that we generated. So that pretty much ties it up for the end of this chapter. I hope you enjoy this, and I'll see you next week. If you have questions, always feel free to email me, and I'll be making another video about the discussion section shortly.